So we're demonstrating our PXIe-GPU, in particular the Catalyst T1000, our entry-level GPU, in a PXIe system, and we're going to illustrate different FFT sizes and the performance that we obtain from them using the GPU. So we have recorded TDMS files onto this RAID drive that we also manufacture called a Trifecta SSD RAID, and we're gonna basically stream them to the GPU. We're going to process different size FFTs, and on this screen here we have different metrics that we can use to observe the performance. So you can see there's the frame size, the FFT size, and the actual time it takes in milliseconds for the GPU itself to process the data, for the CPU to send the data to the GPU and then process the data, and then the total time for the GPU to both process the data and also receive data from the CPU and send the data back to the CPU rather. So that's the total time. Typically, for most applications, it's this middle time that you want to consider because you always have to send data to the GPU. So we've started with an 8K FFT, and let's see how that runs. I can get my mouse. So you can see that the GPU itself is running between maybe 0.3 and 0.4, kind of maybe 0.5. So around 0.4 milliseconds for the GPU by itself. The GPU with the send time from the CPU is about 0.5 milliseconds. I'll stop it. Now we'll go to a 16K FFT. And you see, well, it turns out the time is pretty much the same. It's going to oscillate between like 0.3 milliseconds, 0.2 milliseconds, at about 0.5, 0.6 milliseconds. And similarly with the including the send time, about 0.5 milliseconds on average, maybe 0.6. Now let's go to a 32K FFT. You can see that, and this indicates that the GPU is not very busy. The time to process the data on the GPU is pretty much constant until you get to much, much bigger FFTs. What we are seeing is a variation in the send time to send the larger data. So now we're still in the 0.4, 0.5 milliseconds for the GPU, and about 0.4, 0.5 milliseconds for the send time from the CPU to the GPU. Let's go to 64K FFT. So once again, you see that the GPU itself is between 0.3 and 0.5 milliseconds. Now we're in the 0.5 to 0.6 kind of milliseconds for the time, including the send time to the GPU. One thing to also notice is the RBW. So if you notice, the RBW currently with the 64K FFT is about 35 hertz. You'll see that come down as we start doing longer and longer FFTs. Now we'll go to 128K FFT. You notice the RBW comes down by a factor of 2. It's now about 17.55 hertz. And you can see once again the GPU time is still a fraction of a millisecond. It's 0.3 to 0.5 milliseconds. Now we're in the 0.678 milliseconds, including the send time and the processing time. Now we'll go to 256K. See the RBW came down to 8.8 hertz. And now we're above the 0.3 milliseconds. We're in the 0.4, 0.5 milliseconds for the algorithm time itself on the GPU, and about 0.789 milliseconds for the CPU to GPU send time and the processing time itself. Still less than 1 millisecond for the total time. And good RBW of 8.8 hertz. Now we're going to go to 512K. Notice the RBW keeps coming down by a factor of 2 as we increase the FFT size by a factor of 2. So now you can see we're in the 0.5, 0.6 time frame for the GPU by itself, about 1.3 milliseconds, 1.2, 1.3 for the GPU plus the send time from the CPU. And now we're getting to really good RBW. We're at 4.4 hertz RBW. Now we're going to go to 1 million V1.024 size FFT, so 100, well, a million samples for the FFT. RBW is now at 2.1935 hertz, so very good RBW. And you see that, of course, reflected in the signal. So now so now we have enough data in the GPU to keep it busy. So now you're seeing it. First off, it smooths out a bit, and we're seeing about 1.0 to 1.1 milliseconds, more like one millisecond. For the GPU itself, and about 2 and change for the, including the send time. And RBW of 2.2 hertz, very good RBW. Let's keep going. Let's go to a 2048K FFT, so a 2 million point FFT. Now we're starting to put some load on the GPU. So you see now we're at about 2 milliseconds for the GPU, and we're at about 4 to 5 milliseconds, including send time. There's some excursions here. Now, this is reading a lot of data from disk, and we don't have that optimized fully. So you're starting to see that the file I/O will start to affect this performance. In a future version of this application, we'll have that fixed. So kind of focused on the GPU itself for right now. And it's about 2 milliseconds. And I've lost my mouse. Where's my mouse? There it is. So now we're going to go to 4 million point. So now our RBW is down to 0.5 hertz. Now this is getting, this is severe FFT size. And you can see that we're in about the 4 millisecond range for the GPU, and about twice that, including the time to send the data over from the CPU. So 10-ish kind of milliseconds. And notice that now we're moving a lot of data from disk. So 4, 5, 6 gigabytes per second. And as I mentioned, that's not optimized. And the RBW is very good.